Hi everybody, my name is Bucsay, and I'm going to talk about Mimikatz, how to detect it in alternative ways in a bit. But first, a few words about me, if you don't mind. I live in the UK, I work for NCC Group. I'm a principal security consultant at the moment, and I'm really interested in research, mostly offensive security research, but this talk is about defensive security. I started hacking a long time ago when I was 30 years old. In 2000 I did many other things as well, but that was the main thing and main track that I stayed on. Before COVID I went around and I had several talks around the world. I went to Atlanta, Honolulu in the US and all around the world, Singapore, Moscow, London and other places in Europe. You can find me on Twitter. My handle is on the slide and obviously on LinkedIn as well. So if you want to connect, just send me a message or something. I'm happy to talk and connect here or on LinkedIn. So the talk is about Mimikatz, actually detection techniques against Mimikatz. The original abstract that I shared at the conference was about the first method, the busylight method, but since we did a bit more advanced research on the topic, and there is another detection method that I'm going to share with you, at least on high level. So basically, there were two different detection methods in the previous years, many years that we used. The signature-based, which is mostly based on AVs, use that technique mostly, where you have a snippet, a few bytes or strings from a malicious file, which is in a database, and if that's matching to a file that you have on your computer, then that's going to be blocked by the antivirus. It's a really basic concept, it's working well, but obviously you need to update your signature database all the time to keep it updated and have the latest signatures. The other really widespread detection technique and well-known is the behavior-based. It's a bit more tricky. Basically, in this technique, you are hooking different Win APIs, and if those APIs are called from an untrusted process or in a certain order, then the ADR or AV is going to block the process or possibly kill the process because that must be malicious. So we all know these two techniques. These are widespread, implemented in AVs and EDRs. But in NCC Group, we had a few ideas that we wanted to look into, specifically against Mimikatz, but it wasn't really about Mimikatz at the end. You will see that why. But first, we looked into one, which was the busylight method, and we figured that we can do some stuff against Mimikatz. You can see there is one URL, there is one link on the slide, which is pointing to CobbleStrike. So basically, a long time ago, this method was published in that sense, that if you have a busylight just like this, or similar, which you can connect to your computer, then that can help you detect Mimikatz, and I'm going to show you how. And the second part of the presentation is going to be about a different technique, which is called contriver method, which was partly published and documented by Indians, but I'm going to share the code as well with you. So what's busylight? Busylight is an HID USB device, so you can plug it into your computer, and it can flash in different colors, or it can show a solid color in different, it can show different colors. Let me find my, sorry. Okay, so as you can see, it's flashing now. As I understand, these busylights are used in open offices mostly, where you want to signal your colleagues, your friends, your state of mind. So basically, if you are busy, nobody should talk to you. If it's flashing green, for example, then anybody can talk to you. You are open to new ideas. If you check the source code of Mimikatz, which is open source and it can be found on GitHub, then you can see that busylight is supported by Mimikatz. In 2015, October, Benjamin, who is the author of Mimikatz, introduced this new module, which is supporting 6 different busylights. I'm not sure why he implemented this feature, probably because he just wanted to play around his busylight, but it's there, and from 2015, every Mimikatz release that is released by him or compiled from GitHub directly has this code. What you can do in Mimikatz when you start the tool, basically there is this busylight module, and you can list the different busylights that are connected to your computer. You can test the busylight itself, so it's going to flash in different colors, or you can just turn it off. But there is one really good thing to know about this module, that if you have a busylight connected to your computer and you are running Mimikatz on that computer, whenever you run it, it is going to initiate a thread which is just dedicated for busylight. So it's going to flash it. Every 5 seconds in the background, it's going to send a sequence of bytes to the busylight. So it's going to keep flashing. And when you exit the Mimikatz process, or you kill the Mimikatz process, it's going to kill the busylight as well, at least the flashing part. So up until this point, this was covered by that article. But it's not really feasible to get a device like this for a DC, where you have thousands of virtual machines or physical machines, so you can't really use this device to monitor Mimikatz, right? So we came up with the idea, what if we can create some kind of virtual device, a driver that you can install on your computer, and that will do the detection for you. So instead of having a physical driver device, you are going to have some piece of software which is doing the detection. So I looked into this idea, and I figured out that Windows is great in that sense, that you can create hundreds of different devices, different drivers. You can emulate different devices. So, for example, since this is an HID USB device, you can emulate HID devices in Windows quite easily. And I created a code which does just like that. Basically, it mimics the same device that you can see. And whenever some kind of interaction is made by a software with the virtual device, it logs it, let's say. The code is really small. It was written in C using UMDF, which is User Mode Driver Framework, version 2. I use version 2 because that was the easiest way for me to do the proof of concept, but it only works from Windows 8.1 and up. Obviously, if you are using older version of UMDF, you can support other Windows distributions, including XP, but that shouldn't be used anywhere anyways. Since UMDF was used, the code is running in user mode, which means that it's running under anti-authority local service, which is the lowest privilege user that you can have on your computer, basically. So because of that, privilege escalation is not really a risk. So the code that is running on your computer is going to be in user mode. If there is an attacker who finds vulnerability in the code, it's really hard to exploit because you can't really do privilege escalation. It has nothing to do with the kernel. What it does, basically, my code, whenever there is an interaction with the busylight, with the virtual device, it calls an external DLL from Windows System32 directory. So that's a safe space. Basically, you can put your code into that directory, and my code, the driver itself, will call that code. So you can change the DLL which comes with the code to yours, and you can implement any kind of functionality in that DLL which supports your service, your product. So you can integrate it with anything that you like. So let me show you a little demo. 1 second. So the busylight should be connected. The busylight should be connected to the Windows machine, the VM. And if you run Mimikatz here, okay, it's a bit slow. So it might take a while. There you go. So as you can see, Mimikatz is flashing the device. So that's one way to detect it. If you list the device, busylight devices, it's on the list just right here. And if you exit the process, the flashing stops, right? So we don't need this device anymore. I just unplugged it. And I can install my own device, my driver here, which is installed now. If you check the device manager, there is this HID compliant vendor device, and there's another one, emulated HID device. And if you run Mimikatz now, you won't see anything. It works just like before. You can do whatever you like. You can attack the computer if that's your aim. And if you list the devices, you can see the same device, but actually it's not connected anymore, right? And since I told you that I'm using my own DLL, which is called when Mimikatz stopped, or it's sending key polybs. If you go into the logs, the DLL sends different warnings to the event log. So you can collect those event logs and you can use your SIEM software to do additional things, right? So the first log that you can see here, I hope you can see on the screen as well, it says tool started, PID and a number, so that number is the process ID of Mimikatz. So you can do additional investigation on the process if you want. And every 5 seconds, you can see it from the time and date here, every 5 seconds Mimikatz sends a keep alive sequence to the device as well. So you can keep track for how long it was running. And the last bit, tool stopped, that's when I exited the process. So this is all great. You can track Mimikatz like this. But the reason why we are publishing this research from NCC is basically we were not really happy with the test results. So as you can see, many of the Mimikatz that are out there from open source sources used by mostly security professionals and offensive security professionals that are detected, except a few. So the original version of Mimikatz, which is released, either compiled from source or you can download it from GitHub from the release section, can be detected. Same stuff that if you compile it to a DLL or PowerShell, those can be detected as well. PowerSploit, which is widely used by offensive security professionals, and CAPAC, those can be detected, but the issue is, for us at least, that Metasploit and Bucsay cannot be detected. Neither Mimikatz, but Mimikatz is basically a rewritten, Mimikatz rewritten in Python, so that wasn't really expected anyways. They use the same logic but fully new code. But Metasploit and Bucsay was a hit for us, which is not that great. The reason why it cannot be detected because the module, the busylight module wasn't compiled into that binary. I believe the reason why they did that for both attack tools is purely because of the size. So busylight functionality in Mimikatz doesn't have offensive security value at all. So they just removed it because that made the payload smaller. So that's easier distribute. That was the first method that I wanted to cover. And the second method is the console driver method. Since we were not really happy with the first bit of the research, we were happy about the outcome. At least we know now, and partially we can detect it, but still. We wanted to go forward a little bit and look into other options. So we thought that maybe the console can be a good way to do that. I don't know how familiar you are with Windows, but probably when you open a process monitor or something, Process Explorer, you can see the controls.exe process all around. So that's basically either the controls.exe or the OpenConsole.exe is like a helper process for a command line application to communicate with the console itself. So the communication between the console and the command line application goes through a driver, a device, which is called device driver. This process is using fast I/O to send and receive data from and to this device. So we were thinking maybe we can sniff those IOCTLs in the kernel and get the data from there. So anything that is written on the console, either is input or output, that should go through that process, that should go through that driver device, and we should be able to get that data. So I started to Google this technique. And it turns out that Mandiant has had a really good research on this topic already. They released these articles that are listed on the slide a while ago. They described the method that they used, but they didn't release any code for this. So I was thinking maybe I can write a code and open source it later, since they didn't do that, or I couldn't find it. And there is this software, open source code on GitHub, which is called WinConmon by DFIR, that was released a while ago. It was really good base, but I had to rewrite a few things because it wasn't matching exactly what I wanted to do, and it wasn't working properly for me. So what I did, I created a new source code based on the articles and that code as well, which is using KMDF, so it's kernel module device driver framework. That means that the driver is going to run in the kernel mode instead of user mode. And with that, since this is a filter driver, I'm able to attach to the device that I previously mentioned and sniff the communication between the console and the command line application. Right? So it works just like an AV. With the signature-based detection, I can create the signatures, which are basically just strings, and I can match that string to the console input and output. That's what I do. It's really basic. So whenever it's matching, so for example, it says Mimikatz on the screen, on the console, I can send an event to the event hook, and again, you can use that in your different products and detections. If you want more info on that, I'm really happy to talk to you after the presentation, and hopefully we will have some time for Q&A at the end of the talk. So, going back to the demo for the second part, I'm going to uninstall this because there is no need for it. So, that was phase one. And for the demo, I created a different application, console monitor. So basically it's a GUI application, as you can see, which opens up a named pipe. It's not really important at the moment, but the kernel driver will connect to that named pipe and will send everything that is sent to or received from the console. Sent to or received from the console, and we are going to see that. So instead of matching the signatures just like an AV, just for the demo, I'm going to show you that anything that is written on the console is going to be reflected in that window. So that's running. I'm going to install a driver. This is going into kernel space. It's a bit more tricky. And as you can see, whatever I type into the black window is going to show up in the GUI in the right bottom corner, even the output, right? So anything that's typed is going to show up. That's working from PowerShell, working from the CMD as well. So Mimikatz is there, and the inputs and output is shown. So again, this is only for the demo, just to present, but you can do matching on the input and output, so you can do more than that. So that's working really well. Back to the presentation. But there are some issues, not really issues, this is how Windows works. So it's really great because anything that is written to the console in an interactive or non-interactive way, it can be detected, which is awesome. It's not just for Mimikatz, any console-based application can be logged, tracked, and detected in the same way. So it's not purely for Mimikatz, that was the aim that we went for. The only issue with it, which is not really an issue, again, it's how Windows works, that if you redirect your output into a file, that goes into a file instead of to the console, right? So if you're capturing data on the console, you won't see that, and there is no way to see that. Obviously, you can do another filter driver for the file system, and you can do matching, but that would be just as the same as an antivirus. So there is no point for us to do that. You can do it in other ways. So the feasibility, I mentioned this. We were kind of happy with the results, but not that happy. Let's keep it to ourselves and to our clients. So we wanted to release it just to show people that there are other ways to detect it. Obviously, it's not bulletproof, not foolproof, but it works. I assume that the console driver method is already implemented in the EDRs and XDRs since Mandiant did its research on the topic, but I'm not totally sure. So, regarding the code, there are two codes. For the first method, the busylight method, the first link, it's already published. I published it yesterday, so if you go on that GitHub repository, you can get the code, you can compile it yourself, you can use it. It should be working out of the box, but if you need help with it, if you want to implement it with your own solution, use it in your own estate, I'm really happy to help you. For the second link, it's not released yet, it's private for now, for the next few weeks, because I'm going to another conference and I will do the same talk in a different conference where I will release that bit. So again, please follow me on Twitter if you like. And that's my email address as well. If you have any questions, maybe you can ask it now, or after the talk, or just email me. There is one. Yeah.
You were saying if standard output is redirected to a file, the driver might miss things. If they were redirected to like null or redirect standard output somewhere else, is it still going to catch with this filter driver?
So it's redirected. It's not going to be captured at all. Null is a good idea. Probably you won't be able to do that. But I don't know exactly how null is redirected or data redirected to null, so I need to look into that. Probably file system driver is not, the file system filter driver that I mentioned is not going to work in that case, but that can be good for malware writers and attackers to know. Any other question?
As a follow-up to that, if they were to pipe it into, I know it's still redirect, but if they were to pipe it into standard error or some other means they can collect it, doesn't dump directly to console, do you still have the ability to grab that, or do you have to do some form of memory dump?
So the redirection goes usually into a file, so that goes onto the disk, right? that stays in the memory for that amount of time when it's written. When it's written to null, I think it stays in the memory for a little bit, for a short time, but then it goes nowhere basically. So there is no way that I can capture it with this module that I created. I'm not totally sure, about the answer to that.
Also, not a question, but I just want to say it's very, very clever. Very cool.
Any other questions?
I don't remember if you said, but why did Mimikatz have the busylight module in it?
So I'm not totally sure because I'm not the owner and author, but as far as I understand, Benjamin, who created Mimikatz, started to write the code because he wanted to learn how to code in C, which is a bit funny because this is one of the most used tools out there. And the guy just wanted to learn how to do stuff, and he went really deep into things. So I assume that he had a Mimikatz at home, or his friend, and they just wanted to interact with the device. And maybe it was a good place to put that code into an existing repository, and that was Mimikatz. So I don't think there is a real reason behind, but I'm just guessing here. Any other questions? Thank you, Dan. Sorry, there was one more question there.
Question.
Sorry.
So more of a hypothetical, with this extra busybox code, there was that ability to make this, inherent detection. Obviously, Mimikatz is used, primarily focused as a red team product, but with its usage by APT and ransomware actors, do you think there's like an inherent responsibility of the developers to pay, when you execute Mimikatz, there's this hangout or something. It's just a hypothetical, but what are your thoughts on that, perhaps?
I'm not totally sure I got the question. So if he has responsibility on...
Yeah, if any developers of red team tool, specifically then with Mimikatz, hey, here's some secret thing that lets you detect Mimikatz. Does that sort of make sense? Like, do you think there's some inherent responsibility of the creator of tools, perhaps, if they're not inherently bad guys?
It's a philosophical question, isn't it? I'm not sure. I should be the one to answer this. I don't know. So this is the most common answer today, but I'm not sure. Okay, thank you again. Nice to be here.